In this video, we're going to look at electronegativity, polar bonds and polar molecules. To do this, we are going to focus on the bonding spectrum. On the left, ionic bonds, on the right, covalent bonds, and in the middle, polar covalent bonds. Ionic bonds, electrons are transferred. There is electrostatic attraction between cations and anions, and it's non-directional. Covalent, electrons are shared. There's an attraction between electrons and the nuclei, and we have a defined bond axis. And in the middle, we have polar covalent bonds. So in this video, we're going to focus on polar covalent bonds. Polar covalent bonds. Ionic bonding occurs when electrons transfer from one atom to another type of atom, joining these two atoms together. Covalent bonding occurs when two atoms equally share electrons. Polar covalent bonding occurs when electrons are unequally shared, as the bonding electrons spend more time closer to one atom than the other. Here's an example: hydrogen chloride. The electrons in the HCl bond spend more time near the chlorine atom than near the hydrogen atom. Chlorine has a greater attraction for electrons than hydrogen. This unequal sharing causes the hydrogen atom to become slightly positive, while the chlorine atom becomes slightly negative. The Greek letter delta indicates a small difference. Delta positive means there's been a positive charge, and delta minus means that there is a negative charge. So we know that the Greek letter delta indicates a small difference. Delta positive means there's a positive charge. Delta negative means a negative charge. In the example hydrogen chloride, the chloride showed the greater attraction for the bonding electrons, but the attraction was not strong enough, or is not strong enough, to actually bring about an electron transfer. So we have a polar covalent bond. So a covalent bond forms between atoms with significant different electronegative values, which we call a polar covalent bond, or a bond with some ionic characteristics. To predict which parts of the molecule will have the positive charge and which will have the negative charge, compare the electronegative values of the atoms from on your periodic table. The most electronegative atoms will attract the electron pair strongly, so will tend to be the delta negative. Polar covalent bonds. Problem: draw the structural formula for methane, CH4, the main component of natural gas. Indicate which atoms are slightly positive and which are slightly negative. Is CH4 polar covalent? Let's find out. Here's the solution. Start by determining the electronegativity values of carbon and hydrogen. Hydrogen is 2.20, Carbon is 2.55. I'm going to just use 2.6. So our electronegativity difference is 2.6 minus 2.4, which is 0.4. H will have a partial plus charge, and C will have a partial negative charge. So here is our diagram, carbon in the middle, the 4 hydrogens around, and the hydrogen we said are the positives, and carbon is the negative as it's in the middle. While there is a partial positive charge and negative charge, this is not a polar covalent molecule, and the total electronegativity difference is not great enough to be considered polar covalent. It's only 0.4. So it's a covalent molecule. Now, polar covalent molecules. Is HCl polar or nonpolar? To do that, we're going to use what's called the electronegativity bonding continuum. This shows us the range of the electronegativity differences and the type of bonding that will occur. So here's our solution. So determine the electronegativity values of the atoms used to form the molecules. And we get that information from the periodic tables. So the electronegativity of H is 2.2. The electronegativity of chlorine is 3.16. We are now going to use these values to determine the electronegativity difference, which is 3.16 minus 2.20, which gives us 0.96. But where does this fall on our electronegativity bonding continuum? To find out, we're going to determine where the value of 0.96 is on this electronegativity bonding continuum. There's 9.96, and that's in the polar covalent region. So the value of 0.96 indicates that this molecule is polar covalent. One end slightly positive, one end slightly negative. Now, this table, found in your text on page 93, is a good reference to include in your notes, as it gives the electronegativity differences of a selection of bonds commonly used. I would have this available on a quick reference sheet. The next is a table that summarizes bonding. Bonding between the atoms in a molecule, and this is called intramolecular force. So the first is the ionic bond that involves the electron transfer, resulting in the formation of cations and anions. And cations and anions will attract each other. The polar covalent bond involves unequal sharing of pairs of electrons by atoms of two different elements. Bonds can involve 1, 2, or 3 pairs of electrons. Single, which are the weakest, double, or triple, which are the strongest bonds. Covalent bonds involves equal sharing of pairs of electrons. Bonds can involve 1, 2, or 3 pairs of electrons. The single is the weakest, then the double, then the triple, which is the strongest. This is another table that I would have in my quick reference guide. Found on page 85 in your textbook. Now this table, also found on page 85 of your textbook, is a guideline for predicting polar and nonpolar molecules. It describes the description of a molecule. Could have a single H, an OH at one end, an O at one end, an N at one end, what type of bonding it would be, some examples, and then it outlines the nonpolar format and some examples. Again, useful for this course. So a summary: bond type, polar covalent. An example is water. Now, this is doing the molecular shape and the molecular type. Okay? And we'll be looking at this in more detail coming up.